Okay, example 6. We already know how to do these first couple of problems. So this first one here says partial derivative with respect to x. So I'm going to do it first. So finding the partial derivative with respect to x, we're going to treat y just like a constant. And so treating y like a constant, we're going to, you can think of this as the 4 and the y cubed are both constants. So if you want to group them together in front, you have this big constant, so I just moved it right there next to the 4. You have this big constant times x squared. Any number times x squared has a derivative of 2 times that number, x to the 1. So I'm going to have 2 times this number, x to the 1. Minus, same thing here, we're going to treat y just like a constant. So if I want to group them together, I'll have 6y squared x, and this is just a constant number times x. So if it were just 3x, derivative would be 3. If it were 9x, derivative would be 9. It's just a number x, so derivative is just that number. Derivative of 3x with respect to x is 3, and the derivative of negative 5y with respect to x is 0. All right? And so we just did this one, f sub x. We could also do partial derivative with respect to y, but I'm going to skip that one for a second, and I'm going to move to this next one over here. Add me a pen. All right, and I'm going to find this one, and that is f sub xx, which is the partial derivative with respect to x, and then the partial derivative with respect to x again. So the first one tells you what to take the partial derivative with respect to x first, and we did that already. But now the second one says we're going to take the partial derivative of this one right here that we just found and find the partial derivative of it with respect to x again. So looking at this one right now, partial derivative with respect to x means y is just a constant. So we have this big constant number here times x. Again, if it was 3x, derivative would be 3. If it was 9x, derivative is 9. It's just a number x, so derivative is just going to be that number. With respect to x, the derivative of negative 6y squared is 0. And with respect to x, derivative of 3 is 0. So this is our answer for f sub xx. Partial derivative with respect to x, and then the partial derivative with respect to x again. All right. And so we're still going to come back here. So I found my partial derivative with respect to x there. And then we found partial derivative with respect to xx. I'm going to skip over a second, and I'm going to do this one next. The partial derivative with respect to x first, and then with respect to y. So with respect to x first, we just found that right here. That's in green. So now I'm going to take the partial derivative of respect to x, but this time with respect to y. And so looking at the stuff in green, if I'm taking the partial derivative with respect to y, that means x is just a constant. So for this first term right here, 8y cubed x, I'm going to write it over here. X is a constant, 8 is a constant. If you want to put your constants in front, then you have just this big constant number times y to the third. Derivative is going to be 3 times that constant, y to the second. Okay. Still, with respect to y, derivative of negative 6y squared is negative 12y to the 1, and the derivative of 3 is 0. So this is our f sub x y. All right, now hang with me. We're going to look at that again. But we're going to go back this time, and we are going to find, keep adding my stuff here. We're going to find the partial derivative of the original function with respect to y. So looking at my original function here, with respect to y, the 4x squared is just a big constant number times y to the third. So I have just some number times y to the third. Derivative is going to be 3 times that number. So with respect to y, I'm going to have 3 times that number, y to the second, minus, with respect to y, the 6x is just a constant. They're both constant numbers. So I just have this constant number times y squared. Derivative is going to be 2 times that number, y to the 1. With respect to y, 3x is just going to become 0. And with respect to y, the derivative of negative 5y is negative 5. And so I just found the partial derivative of my function with respect to y. All right. Now I am going to look at f sub y. That means I'm going to take the derivative with respect to y first, which we've already done, and we got this right here. Now I'm going to take the derivative of that term with respect to y. So I'm taking the derivative of this yellow term with respect to y again. So with respect to y, x is just a constant. So I have this big constant number, 12 times x squared. It's just a big constant number times y squared. So I'm going to have 2 times that number, y to the 1, minus, with respect to y, derivative of 12xy. 12x is just a number times y. If it were 2y, the derivative would be 2. If it were negative 4y, derivative would be negative 4. So the derivative is just negative 12x. And the derivative of negative 5 is 0. And then I'm going to show you something. If I take the derivative with respect to y first, which is this yellow part here, and then I take the derivative with respect to x. Let's look at that. So I took it with respect to y in yellow, and now I'm going to take derivative of that yellow part with respect to x. So that first term right there, 12x squared y squared, I'll write it here. The 12, with respect to x, the 12 and the y squared are both constants. So if you want to write them together, you have this big constant times x squared. Derivative is going to be 2 times that number, x to the 1. And then with respect to x, if we're looking at this term, 12xy, the 12 and the y, that's just a constant number times x. So the derivative of any number times x is just that number. Now look at this. These two are the same answer. F sub xy equals f sub yx. It doesn't matter if it's 24 times x times y squared or 24 times y squared times x. We got the same answer. All right, so we're going to practice this again on part B. If you want to pause the video and try it yourself first, go ahead. Okay. So first thing I'm going to find is f sub x. That is the partial derivative of this with respect to x. So I'm going to do this the second method. I just used my first method on all of those. I'm going to try this one with my second method for those of you who like the second method better. So that's where you just zoom into your x term and take its derivative. So the 2 is going to stay there, the y is going to stay there, and I'm going to take the derivative of x to the 5th, and I get 5x to the 4th minus, just taking the derivative with respect to x, the 3 and the y to the 4th stay there, and the derivative of x is 1. So I'm going to clean that up a little bit. And I get 10x to the 4th y minus 3y to the 4th. That's f sub x. All right. Then say I wanted to find f sub xx. Now I'm going to take the derivative of the red part with respect to x. So the 10 will stay there, the y will stay there, and the derivative of x to the fourth would be 4x to the third. With respect to x, the derivative of negative 3y to the fourth is just 0. And so I get f sub xx equals 40 x cubed y. Then if I want to find f sub xy, I take derivative with respect to x first, which is the red part up here, and then I take the derivative of that red part with respect to y. So with respect to y, the 10x to the fourth just stays where it's at, and the derivative of the y is just 1. With respect to y, this is just a normal one. 4 times negative 3 is negative 12y to the third. And so I get f sub xy equals 10x to the fourth minus 12y cubed. Okay? So then I'm going to come over here and I'm going to find f sub y. So back to my original function right there. I'm going to take the derivative of everything with respect to y. And I'm using my second method. So I'm going to just write down everything except the y. And then I'm going to focus on the y term. Derivative of y to the 1 is just 1. Minus, with respect to y, I'll just write those two down. And the derivative of y to the fourth is 4y to the third. Then I can clean that up a little bit. 2x to the fifth minus 12xy cubed. So then, if I wanted to take the partial derivative with respect to y, then with respect to y again, this first term here, derivative of 2x to the fifth with respect to y, that's all just a big constant, so that would be 0. This next part, with respect to y, I'll just write down that part, and then the derivative of y cubed would be 3y squared. And so I get negative 36xy squared. And finally, if I wanted to find f sub yx, that means I'm going to take the derivative with respect to y first, which I just did, and it's right here. And now I'm going to take the derivative of that one with respect to x. And so for 2x to the fifth, that's just a regular 10x to the fourth minus. And then with respect to x, the 12 and the y cubed will just stay, and the derivative of that x term is just 1. And so I have 10x to the fourth minus 12y cubed. And if you're checking to see if you did it right, these two will always be the same answer.